Welcome you all. In this video we will see how we can generate and visualize ramp signal in MATLAB platform. Ramp signal is a kind of signal where whose amplitude is linearly changes with respect to time. For say example, if you consider the current in the conductor, so whenever we apply the voltage, the current is going to linearly increase or decrease. This kind of signal is referred as a ramp signal. So ramp signal can be mathematically represented in both continuous and discrete form, as you see here. So in a continuous time frame, the ramp signal is represented as whenever time greater than or equal to 0, the ramp signal is equal to time. And similarly in a discrete time, whenever the n greater than or equal to 0, the signal is n, and all other time the signal is 0. Now let's see how we can generate and visualize the signal in MATLAB platform. So first I just open new script. As we did before, I just first create x-axis data both for continuous time and discrete time. So let's copy this and keep it here. Right, so let's save this file. So I'm going to name this file as, let's say, ramp signal. Right, now let's change this title to ramp signal. Right, now we have to create amplitude to make a ramp signal plot. So already we made a time signal as well as samples for a discrete time. Now I need to create an amplitude. And as we know that in a ramp, when time t greater than or equal to 0, the ramp signal equal to the time, right? That is the function. So let's see how we can build this. So the point is the amplitude, let's keep that as y1 equal to time, right, whenever time greater than or equal to 0. So when that condition holds true, then y1 has to be considered as t. So for that, what I'm going to do is, again I go with the logical operation. So now with this I'm going to multiply the condition whenever the time greater than or equal to 0. So let's open bracket, t greater than or equal to 0. So now this condition check whether time is greater than or equal to 0. So whenever it is true, then it will take that output as 1, and that will be multiplied with the time. Now this I wish to do for each of the time step. So whenever you want to do this kind of operation for all the time steps, like for a vector, we have to keep, there is an operator called dot int. So this is actually the multiplication of each variable in the vector with this values, right? So this is going to create a vector with a condition whenever t greater than or equal to 0, the signal will be there. Whenever t less than 0, obviously this is a false condition, so the output is going to be automatically 0. For say example, let's take time as 2. So whenever time is 2, which is actually greater than 0, so this is a true condition, so it is going to give output as 1, which will be multiplied with the time signal 2. So 2 times 1, 2 will be assigned to the y1 automatically. Similarly, when you assume that t is minus 2, so which is a false condition, so it takes automatically 0, which will be multiplied with minus 2, so the answer is assigned as 0, right? So this will create a appropriate ramp signal. So now we built the amplitude. Now I go for a plot. So let's use a plot command. First I call the x-axis data, which is t, and then followed by y-axis data y1. Right, now we go for labeling the plot. So I just straight away copy from the previous one. Let's keep it here. So x-axis time, y-axis amplitude, and title I wish to keep this as ramp signal in continuous time. So right, so this is going to make a ramp signal in a continuous time. Now let's do the same thing for a discrete time. So I just first keep a subplot. So subplot, I'm going to keep it for a position 2. Okay, so I declared the subplot. Now I have to create a magnitude as we did in a continuous time. So let's take that amplitude as y2, which is equal to now for the discrete time, whenever n greater than or equal to 0, the signal has to be equal to n, right? That is a function. So let's keep now y2 equal to n whenever the n is greater than or equal to 0. So for that again I go with the same option what we did before. So star int. So this is going to do the multiplication for each of the n value, right, with a condition of n greater than or equal to 0, right? So whenever n greater than or equal to 0, this is true, and that will be multiplied with the corresponding n, and that will be stored on y2. For say example, let's keep n as 3. Then if n is 3, then y2 has to be 3, right? So if n is 3, this condition is true, then it is going to give output as 1. That is going to be multiplied with n is now 3. So 3 into 1, 3 will be assigned to y2, right? Similarly, let's say if n is minus 3, right? So minus 3 means then we have to keep y2 as 0 as per our function, right? So when it n equal to minus 3, then this is the false condition, so it give output as 0. So 0 will be multiplied with the 3, so it is going to make y2 as 0. So in this way, for all the positive values, the y2 will have n. For all the negative value, the y2 will be 0. So now we made an amplitude. Now I am going for making a plot. So for discrete, we'll be using a stem signal, stem command. So first I call the x-axis data, which is n, then followed by y-axis data, which is now y2, right? And then we just take up the labels. Maybe we can copy it from the previous one. Right, so x-axis sample, y-axis amplitude, and title let us keep ramp signal in discrete time. Okay, now just save this and run the program to see the signal. Right, you can look here. So this is a ramp signal in a continuous time, this is a ramp signal in discrete time. You can see once time getting increased, the amplitude also linearly getting increased. Similarly, in a discrete time, you can see when samples getting increased, and linearly the amplitude also getting increased, right? So I hope now you understood how we can generate and visualize ramp signal in MATLAB. Thank you.